The random variable x is normally distributed with a mean of 10 and a standard deviation of 2. Using the 68, 95, and often in questions 95 rather than 95.4 as mentioned in the intro is used, 99.7 rule, calculate the following. So if we look at part A, it says the probability that x is between 8 and 12. Now if we know the mean is 10, then quickly draw a normal. And we're talking about 8 to 12. So we're talking about this area here. Now the standard deviation is 2. So that means that this is minus 1 standard deviation this side and plus 1 standard deviation that side. So we're within 1 standard deviation of the mean. And we know that that is 68%, and therefore the probability is 0.68. So let's look at B. That's between 6 and 12. The mean is at 10. And if we have 12 here, 6 is over here. And remember the standard deviation is 2. So this is take away 2 standard deviations from the mean. And this is 1 standard deviation. So what we want is this area added to this area. So this is going to be half of the 2 standard deviation figure. So in other words, it's going to be 0.95, which would be 2 standard deviations either side, divided by 2 because we've just got one side. And this side is going to be half of the 68. So that's going to be 0.34. It's just like in this one here. It would be 0.34 this side and 0.34 this side, making up the 0.68. So that's 0.475, add 0.34, and that gives us 0.815. And then finally here, we've got the probability that x is between 10 and 16. So this is our normal curve. This is 10, this is 16, and of course 16 is 3 standard deviations. So we're adding 3 standard deviations to the mean. And we are only looking for this area, 10 to 16. So in other words, that is going to be 3 standard deviations to 99.7, but it's going to be half of that. So it's going to be 0.997 divided by 2, and that gives me 0.4985.